Okay, here is one more example. So we have this rod here which is massless, does not have any mass, and it holds a block of mass which is 2 kilograms. Now the system starts in such a manner that it has initial angular velocity of 1 radians per second and has an angular acceleration of 2 radians per second square. Now this rod will fail or break if the radial tension, which means there will be a tension in the radial direction, exceeds 100 newtons. So the best it can tolerate is 100 newtons in the radial direction. That means the centrifugal force in the radial direction should not exceed more than 100 newtons. The question is, after how long will the rod break? That after what time is the rod going to break? Okay, so how should we solve this problem? First of all, and there's one more thing I should have given, and the length of the rod is 0.5 meters. Okay, so after how long will the rod break? First of all, let's calculate at what velocity the rod is going to break. You see, as the angular velocity is increasing, the velocity is also increasing. So here, this is the angular velocity, and because of that, the velocity is also increasing, the tangential velocity. As tangential velocity is increasing, the centrifugal force is also increasing. So if this is given, and you know that if it increases, it is going to break. So at what velocity this rod will fail? So all we have to do is set up this equation: mv square over r, let's call this v max because that is the maximum velocity at which it will fail, equals t max. And if we do that, we get 2 multiplied by v squared divided by 0.5 equals 100. And if we solve this, we get v equals 25 v square equals 25 radians per second square. And if you take a square root, we get v equals 5 radians per second. Oh no, sorry, this should not be radians per second, this should be actually v square is 25 and v turns out to be 5 meters per second. This is velocity, it's 5 meters per second. Okay, we have the velocity. Now what is the corresponding angular velocity for this? Let's call this max everywhere. Is the maximum okay, so omega x we know is going to be v max divided by r, that is 5 divided by 0.5, which gives me 10 radians per second. So at this angular velocity the rod will fail. But after how long we are going to achieve this angular velocity? Well, we can use one of the kinematics equation, which says omega f equals omega I plus alpha t. What is omega f? This is what we want. What is omega I? We know it's 1 plus alpha. We know alpha also, which is 2 multiplied by t, and that gives us t equals 4.5 seconds. So the rod will break after 4.5 seconds. And in the next lecture we'll introduce a new topic which will be related with rotation.